Hello, am I audible?
Yes, doctor.
Yeah. Is my
Okay.
PowerPoint slide visible?
Yes, yes.
Okay, thank you.
Please go ahead with your presentation.
Yeah. So greetings to all the participants. And I extend my thanks to the organizing committee, Stainless World Congress and the Catalysis Forum members for giving me an opportunity to deliver a talk today in this international event. So my talk entitled Bio-derived carbon and its composites for water pollution control. So our intention is to make some materials which are sustainable, which can go for water pollution control. So I belong to the country India, and this is my email ID. If any future interactions are there, we can go for with this email ID. So next, my talk is actually involving this subtopics. We discuss a little bit on water challenges, the current scenario, the sustainable solutions regarding this water challenges, the current research we are doing here, and particular to biomass, bio-waste-based carbon. Here I focus on cheap paper-based carbon. Then the photovoltaic performance in degrading to model dyes and the future perspectives. So going through the increasing population, pollution, we have encountered the water crisis, the global water crisis giving us a question mark on drinkable, potable water. According to UN Environment Program 2016, we can say that there is a drastically changing climate situation, and that report says that half of the world's population will be under water stress by 2030. So water stress means here the water use with respect to the water available in that area, particular area. So this will bring a rise to many issues on health, food, economy worldwide. So in this picture map, we can see that there are many colors. So these colors, we are more interested in the red and brown color. And these colors, I think, various places are having this color, which implies they are under water stress, including my country, India here. So we are more into the emerging water solutions which are sustainable. We celebrate World Water Day every year, 22nd March, with a current goal of UN Sustainable Development, that is on water and sanitation by 2030. But this year, in 2024, the theme is water for peace, because in this water crisis, there is an ecological disturbance across the globe. And we seek solutions which emerging technologies, for example, with low-cost water quality sensor, water quality monitoring, affordable desalination, precision agriculture, and recyclable treatment materials. And many more are there to discuss. Now, when you talk about this emerging water pollutants, there are many water pollutants coming from industry, agriculture, so many other fields. So we start with the drugs. So pharmaceutical industry is the main area from which, according to the Global Health report, recent report by 2022, 80% of world wastewater discharged into water resources. Similarly, the second item is the pesticides. So these pesticides, 710 tons of pesticides are coming into waterways every year. Similarly, the organic dyes. So organic dyes takes the maximum pollution part. So 1/5 of water pollution comes from textile dyes only. Then the heavy metals. The heavy metals which are coming from mining sector, e-waste, the biomedical sector, and some chemical industries. they pollute the water enormously, according to a recent report in 2023. Then comes the micro or nanoplastics, which are the emerging pathogens right now. And 18 billion pounds of plastic waste comes to the water sources, mainly sea and oceans. So what is the scenario currently is the water polluted with all these pollutants. So our main intention goes to find out a solution. And out of many feasible solutions in this discussion, my intention is to go for recyclable treatment materials. And these recyclable treatment materials, we focus on adsorbents and heterocatalysts. And these materials, because of amid the situation of pollution, global warming, and climate change, we want to have sustainable materials. And these should be environment friendly and support sustainable development, ecological development, and it should be green by nature as well as by synthetic protocol. So here, coming to the polluted water treatment methods, we adopt two common processes, that is adsorption and catalysis. This catalysis may be photo-driven or electro-driven, using natural materials and natural phase. And these natural materials, the source is the biomass and biowaste. In this biomass, we can categorize into four types coming from agriculture crops, alcoholic fuels, organic waste, and woody plants, wood waste. Okay? And commonly, if we go through the literature, many carbon materials are prepared using many vegetable fruit peels and leaves. Now, coming to our work here, we have used this 5 types of biomass and biowaste to get the bio-derived carbon and its components. The first one is coffee tea residue and fallen waste leaves, chili peppers, vegetable residues, and food residues of peels. Now, in this discussion, my area of discussion, my area is selected as chili pepper based carbon in its nanohybrids with TiO2 for water pollution pollutant removal. And the team members involved in this particular work are some of the research scholars, some BTech students who are doing the project in this area. And part of the work is done in the Material Science Center in the Indian Institute of Technology, Kharagpur, along with in my institute facilities. Now coming to why chili pepper, what is the specialty of chili pepper? If you want to discuss, let's go a little bit into the biological part. So the name is Capsicum annuum L, and chili pepper is selected on the basis of its abundance, its perennial nature, it's available throughout the year, and its cost effectiveness. And if you see the composition of chili, it consists nearly 90% of water, nearly 9% of carbohydrates, some proteins, and the main elements in this are mineral K and vitamin C, and some fats and phosphates which I mentioned, but there are many minor elements present too. We have taken the area spectrum of dried chili powder. We have seen that it mainly consists of carbon, oxygen, nitrogen, potassium, and phosphorus. So with this basic inputs, we are interested to make some carbon out of this fresh green chili peppers. For synthesis, so the left side figure shows that we have taken fresh green chilies, we cut into pieces, we dried, and we made into dried flakes. Then we mixed with camphor, which is a self-propagating agent, to burn it, combustion process, to make a fine powder. And this powder, we found that having so many pores, which are characterized later by many characterization techniques. And if you see the chemical composition, chemical compounds which are present in this chili, fresh chili nectar consists of capsaicin, which is the pungent agent present, is a major part in capsaicin, chili pepper, and this glutamic acid, ascorbic acid, and aspartic acid. And it is very noteworthy here that all these compounds consist more or less this nitrogen element. So it is modeled here that when we burn over combustion, this nitrogen combines with the carbon network present there, carbon rings, to form a transition compound, that is benzo-oxynitric hydroxide, which subsequently gives rise to this carbon network. This is sp2 network with some nitrogen moieties of functional groups. And eventually this is treated as a porous plate or plate-like structure. And this way will go for many characterization to see whether pores are present or whether it's a plate-like or not. This TEM and SEM and TEM images, we can see the first line shows the SEM image, which shows the plate-like or flake-like structure of the carbon. And second line here, the TEM image shows that is having mini layered structure, a little bit layered structure. The extreme right figure shows the diffraction pattern, which is a ring-like structure, which says that it is a polycrystalline in nature. It's not single crystal. And the last line shows how the carbon plates are present. Many layers are present. It's a layered structure. And A1 picture on the right side bottom shows that each layer, this layer structure has a thickness of 20 nanometers. So with this, we have zoomed the TEM images to see anything else is present which are of interest to us. That is, here we have found that some twins are present, some this locations present. So, which are very important in photocatalytic relation to the pollutants. And these twins are modeled here in this diagram. So one side, one type of sp2 network with some crystalline plane combining with another plane, giving us a twin boundary here. So this is how we have modeled some of the twin boundaries or twin planes. And the right side figure shows the XRD pattern of the carbon with the inset pattern giving you the XRD for the as prepared carbon sample. When we anneal the sample in vacuum at 400 degrees centigrade, we got similar type of pattern, giving us 3 important peaks, and these peaks correspond to sp2 type of carbon. We have found that intensity, relative intensity of these peaks, these peaks are broad, and they can give us an yes, am I audible? Excuse me. Hello, am I audible? Hello. Hello, I'm audible.
Yes, we can hear you. But I'm audible only.
Okay. Thank you. So I'm continuing with XRD. So here the 400 N sample also giving us many peaks here, and we have modeled the structure probably with this porous in nature, and we have some nitrogen functional groups attached to that pore boundaries. Yeah. Next. In order to see whether pores are present or not, whether the structure is porous in nature, we have gone through the nitrogen absorption and desorption isotopes, and we found that there are mini pores and having a pore volume of 0.5, nearly 0.5 centimeter cube per gram with a pore area, surface area of 335 meters square per gram and having a pore size of nearly 4 nanometers. And this second bottom figure shows that the maximum pores with size of 2 nanometers here, radius size is present. That means it is major porous structure, which is very, very important for pollutant degradation. The right side figure, the first top figure shows the IR spectrum. So this FTIR spectrum of two types of things will taken. One, the black one is the chili nectar, chili juice, and here we can see that there are certain peaks which correspond to the chili juice because of the compounds present. But interestingly, for the blue and green, which are nothing but annealed as prepared in the annealed carbon, we saw that a new peak emerges here at corresponding to 2346 wave number. And this new peak is nothing but the CN stretching band. And this is very sharp, indicating that nitrogen is doped into the carbon, along with some signature bands here corresponding to the sp2 nature of carbon, C11C. And the lower figure shows the Raman spectra. The first one showing you the D and G bands. So this DG bands confirms the presence of sp2 type of graphene, that is graphene like carbon. And the second diagram, Raman spectra, indicates the 2D bands and harmonics of these 2D bands. Many 2D bands are present. This indicates many defects, presence of many defects here. Now coming to XPS band, XPS spectra, we are interested to know what is the nature of this N-doping. What is the valence states of this nitrogen? So this surface spectra shows that the material, which is annealed at 400, has carbon, nitrogen, oxygen mainly, with the percentage which is mentioned here. Then we have gone to the high resolution spectra to confirm what is the nature of carbon. And we have seen that the most prominent peak is belonging to sp2 nature of carbon. And then oxygen single peak is there, which is coming to the functional group attached to the carbon. Then we have nitrogen. Nitrogen is a broad band which consists of 4 bands. So it is deconvoluted into 4 important bands, and these bands give us the following information. We have these bands at different positions, giving to 4 types of bondings of nitrogen to the carbon. So one is pyridinic, which says that nitrogen directly goes to the carbon place. So nitrogen substituting carbon, and that is about 30% present in the carbon. Pyrrolinic, that means carbon functionalizing as a functional group to carbon, 30%, and oxidized nitrogen, which is making a triple bond with carbon, 35%, and graphitic, that is inner functional group. So this indicates that nitrogen is present in different valence states and different configurations in the carbon. This is the model showing the presence of nitrogen in these configurations. Now to find out the photosensitivity of this material carbon, we have taken EIS spectroscopy and this impedance spectroscopy shows that under the irradiation of light, the carbon resistance goes down from 5 kilo ohms to 3.7 kilo ohms. That means it is photosensitive. So electrons are photo excited by in this carbon. And the second graph shows us very interesting that there is photocurrent generation by irradiating this material with light. So making light on and off, many times we can see that there are photocurrent, photocurrent of different, a little bit different magnitude are generated here. And this downtrend is observed. It might be because of the dynamics of the generated electrons going to the surface or trap states. So we are interested now in this characterizations to find the photocatalytic status. Because of the presence of pores, And because of the presence of sp2 graphene like carbon and nitrogen presence, we are interested to see whether we can degrade the dye under visible light. Usually carbon, in many reports, we have taken this carbon as adsorbent, but photocatalytic property is not extensively observed in literature. So we are interested to find out visible light responsive property. And this first diagram shows with methylene blue as the model pollutant. We have seen that the absorption is around 76%, large amount of absorption. And this methylene blue actually is linear, so it goes into the planar structure of carbon. That's why huge absorption is observed. Along with this absorption, we have seen that under visible light radiation, the methylene blue intensity of the absorbance of this methylene blue decreases, which indicates that methylene blue is degraded. And this degradation is represented here, and we have found that this catalytic process is about 70%. And this photograph shows, the last photograph shows how the methylene blue, which is blue in color, the color changes subsequently upon periodic light irradiation of carbon wastewater containing carbon. So we are degrading the methylene blue. And this middle figure shows about the schematic diagram explaining the mechanistic pathway of how the electron generation takes place under light irradiation and how this charge transfer takes place so that we can have a very fast redox reactions degrading the methylene blue. Similarly, we have taken a charge neutral organic compound, that is chlorophenol, which is mostly available in pharmaceutical or say clinical sections. This chlorophenol is again a planar structure, and we are interested to find out the adsorption. We have 62% adsorption is possible with the carbon prepared by us, and this is the degradation profile of this two chlorophenol. And we have seen that photocatalysis is around 60%. So this right side figure shows the mechanistic pathway of how the chlorophenol compound degrades with the help of photoexcited electron and photons. Because of enormous adsorption, we are interested to find out the isotope in which way the adsorption takes place. We found that this is a line type having a fitting of 0.99. So line means here monolayer adsorption takes place homogeneously. Now we are interested to find out the rate of photocatalytic reaction. So we have taken both first order and second order. We found that this methylene blue and 2-chlorophenol both degrades in the first order kinetic way, giving a kinetic rate of 0.003 and 0.001 per minute respectively. And we have checked the recyclability of this carbon, and we found that for each cycle of using carbon, we have a degradation efficiency loss of 1%. So we can use 5 to 6% efficiently for degrading the same type with the same carbon. So important outcomes from this carbon itself is like chili derived carbon from chili pepper itself, and we have nitrogen oxygen functionalization in situ during synthesis only. We don't have to go for the extra steps and extra chemicals for nitrogen functionalization. And it's a very big pollutant absorption on this carbon. 75% for methylene blue, more than 60% for chlorophenol. It has a significant visible light transmission for photocatalytic activity with a very good rate of degradation. For 2-chlorophenol removal is 87%, total removal I'm talking about. And for methylene blue is 92% with this rates. Now, these are the related publications with this carbon. So first one is the publication, the second one is the patent publication. we are now interested to what actually happens if I take this chili paper and TiO2 together, making the composite. And wrapping the content fastly, I can show you that TiO2 carbon monohybrid can be prepared by simple synthesis. That is, we inject titanium precursor directly into the fresh green chilies. We make them dry in air ambient for a few days, and we finally got some dried powder inside this chili, dried chili. We powdered the green chili, and we, along with the camphor, we found that to find out this powder. This is the TiO2 carbon composite powder. And we so exactly we found that this material consists of all the peaks corresponding to anatase TiO2. Anatase TiO2 is a phase which is very good for the catalyst. And there is no peak corresponding to carbon here. This insert shows the as prepared sample, and these two graphs here, many graphs, blue and red color shows the composite annealed at different temperatures, 400 and 600. Now, quickly going to the microscopic images here. The sun images shows that they are particulate in nature, having some coating of carbon here on TiO2 nanoparticles. So it's a nano hybrid, we can say. And this TiO2 is polycrystalline in nature, as evidenced by this diffraction pattern. And here, bottom figure shows the Raman spectra of this composite powder, which shows that this peaks all corresponding to TiO2 anatase. In addition, that we have a very weak bands here available, which correspond to D and G bands of the graphene-like carbon, which wrap the TiO2 nanoparticles. Now we are interested to again go for the two pollutants, methylene blue and 2-chlorophenol, and we found out that this time the rate of degradation is increased. So here rate is 4.2 10 power minus 3 minute per minute, which was earlier 3 into 10 power minus 3. Similarly, here for 2-chlorophenol, it is increased. Repeatability tests also we have done. So the same sample taken 45-6 times, we have seen that there is a small decrease in the degradation efficiency. And road one shows the mechanistic pathway for degradation of the pollutants. So first, we have the excitation of electrons, and this electrons will pass through different energy levels in this nanohybrid, including methylene blue. And this charge separation brings rise to the redox reactions at different sites. So quickly going to the third type of the composite, we have European nanohybrids, where we have taken europium as a low quantity TiO2 nanoparticles. The same way we have prepared the samples as we have done the TiO2 composites, and we have seen here that the catalytic degradation with this sample is even faster than the previous one. So these are the different graphs for where TiO2, which is annealed at 400, TiO2, which is annealed at 600. So this table shows the different photocatalytic and absorption parameters of the prepared samples, all these samples. This summarizes that chili carbon has a degradation rate of 0.003, 0.001 towards the two compounds. And when europium group, the TiO2 nanohybrid shows the highest degradation rates. So this europium, which goes to TiO2 surface, increases the light absorption, as well as it enhances the photons, electrons, and charge separation, so that we can have higher rate of degradation. what are the conclusions of this work is? We have made a sustainable material simply using chili paper, very cost-effective chili paper as a precursor. It's a very using a very clean and simple method without using costly equipment at all. And we have instituted nitrogen functionalization. These samples have shown very good absorption. In addition to absorption, we can have a very good catalytic activity too. And here we have tested with methyl blue and blue fluorophenol. In fact, we can go for other pollutants which are cationic in nature or neutral in nature. And the repeatability also is very good. We can go up to 5 or 6 cycles. The future research with this chili-based nanostructures is that we are interested to preparing adult filters for the running water purification, and we want to explore the electrophotolytic properties, and we want to have some composites other than TiO2, some other metal oxides. So these are the references for which I have taken the data. And thank you for active listening. And I invite any questions from the audience. Thank you.
So thanks a lot for your presentation, Professor. Any questions from the group? Okay, so could you please permit us whether to upload your presentation in our YouTube channel?
Okay, definitely, I will do that.
Okay, thanks a lot, Professor, for your presentation. So let's move on to the next presentation. I would like to welcome Dr. Noor Asrina Hamid.
Yes, I'm here.
So from University Sains, Malaysia. Doctor, could you please share your screen?
Okay, now I'm sharing it. Just a moment. Oh, I cannot share because I need for the other participant to stop sharing.
Okay,
Only
okay.
then I can share.
Okay, okay. Dr. Rajeshwari, could you please close your screen? Hello?